Question 6, comprehension question here. Measuring the speed of sound in air. Some stuff, words, you need to read them. Suggest an experiment that will demonstrate the wave nature of sound, line 1. So we need any experiment that proves that something is a wave. And the one you need to learn off by heart is diffraction. So get the waves to diffract when travelling through a gap, e.g. a door or something like that. Okay, so there's your door, an open door. Sound waves come in and they diffract on the other side. Using the value for the speed of sound in line 6, that one, calculate the time between seeing the flash of the gun and hearing the bang at a distance of, well, that's 2,500 meters, isn't it? Let's write that down. So we have speed is equal to distance over time for constant, for zero acceleration. So then we have time is equal to distance divided by velocity. So that's equal to 2,500 divided by 480. 2500 divided by 480 is 5.2008. So that's 5.2 seconds to SF, which is what that is to. Explain why it's necessary to assume that compared with the speed of sound, the speed of light is infinite. Line 5 there. Okay, well, what we've done here is we've assumed that the light has arrived instantly for our maths, because we said all the travel time is speed of is done by the sound. So in the maths we have assumed the light arrived in zero time. Oops. So the light arrived in zero time, which means the speed of light is infinite. I'm just going to write infinite now. Okay, it's a bit of a weird question, that one, because it's kind of circular argument, really. Explain one observation that could have led this chap to conclude the speed of sound waves does not depend on the frequency. So line 7, you realise that speed of sound does not depend on frequency. Well, if it did depend on frequency, then the different frequencies would arrive at different times, and that would change how the sound actually sounded. So because the gun sound will be a mix of frequencies, if it sounds the same but quieter at 2,500 meters, they all arrived at the same time. So speed does not depend on frequency. Okay, so because the gun sound will be a mix of frequencies, if it sounds the same but quieter at 2.5 kilometers, that means that all the frequencies must have arrived at the same time, so the speed does not depend upon the frequency. Right, question 6.5. Explain how the value obtained by these two people was much better than that obtained in line 8. So this one, why is that value better than that value? Well, it's because that value is closer to our current accepted value. So because 350 meters per second is closer to the current accepted value, which apparently is this 331.29 meters per second. So, than 480 meters per second. So, because this one is closer than this one to this one, that's why it's a better answer. The speed of sound c in dry air is given by this, where theta is the temperature in degrees C, K is a constant. Calculate K. Okay, this is a really easy question. You don't need to have ever seen this before. You just rearrange it. So theta is 0, which makes it even easier. So you've got K is equal to C divided by theta plus 273.15. So what's that equal to? C is this number here, 331.29, and we've got to divide that by the square root of 273.15. So let's do that. So I'll do the square root of 273.15 first, and then I'll do 331.29 divided by that answer. Gives us 20.0450768. Right, why on earth is this 2 marks? Because it's so easy. Well, the second mark might be for the significant figures then. So let's have a look. That one's to 5. That one's to 5. We've put the temperature in as 0, so let's assume that's 0.000, otherwise we're doing it all to 1 SF, so it would be just 20. So 5, 5, so we need to write our answer to 5 sig figs, which is that many there. So 20.045 to 5 SF. State the steps taken by the scientific community for the value of a quantity to be accepted. Okay, if you want something to be accepted by the scientific community, then you publish your results and your experiment, and then it gets verified by independent parties, and that's the scientific process. So the method and results must be published, and then verified by third parties, independent scientists. So the independent scientists will both repeat this experiment and make sure it works, and also do other ones which try to get the same answer. So 2 marks, you've got to first of all publish your results and your method, and secondly other people have to verify what it is that you're doing. Okay, that's the end of the first section. We're now on to the multi-choice.